So when we look at linear equations or linear relationships, there's two forms that we kind of focus on. There's actually three forms. The two forms we focus on is the slope-intercept form, because this form gives us the slope and the intercept. So the two things that describe a straight line relationship, the angle, slope, and some position, are characterized with the slope and y-intercept. The other form is a point slope form, and the point slope form is very, very useful. Okay, so the point slope form has a slope the same as the slope of the y-intercept form, but also has a point. Okay, and just like the y-intercept is some point, the point given is just fixes the line in a particular place. And so the point slope form acts in the same way as the slope-intercept form. However, this is a little bit more flexible, as we're allowed to use any point to fix the relationship, the linear relationship in space. We're most probably familiar with the y-intercept form, so we'll start with that. So here we have the relationship y equals 3x minus 2, and we can generate a table of values. One point that always should be on the table is the y-intercept point, or the starting point. So when x is 0, y is negative 2, x is negative 1, y is negative 5, x is 3, y is 7, x is 4, y looks like it's going to be 10. Okay, and then we can plot these coordinates. Negative 1, negative 5 is a coordinate. That y-intercept is a point on the graph. Okay, maybe I'll do that point in green, in blue. Okay, so this is a special point. This is our starting point. Okay, the y-intercept coordinate, and it shows up in our equation. And we can plot a couple other points: 3 over 7 up, okay, 4 over 10 up, somewhere around here, and then we can see that that generates a straight line relationship. Okay, so it kind of goes up through here to there in a straight line. Okay, and we can make a table of values here. It's important to recognize that we have the relationship can be expressed as an equation. Okay, it can be expressed as a table, and it can be expressed as a line in space. So the slope y-intercept form of the graph is very useful because we can see the properties, the physical properties of the graph in the actual equation. Okay, and we can actually find those pieces when we rewrite them in the slope-intercept form. So this is called the general form equation, and if we want to write the slope-intercept form, all we do is solve for y. And in that form, y equals, we can then identify the slope and y-intercept. So when I rearrange this equation, I'm just going to solve for y. So I'm going to move the 3y to one side, and I get 6x plus 9. Divide both sides by 3, so I end up with 2x plus 3. And by doing so now, we can identify the slope and y-intercept. So here's my slope of 2, and the y-intercept is going to be at y equals 3. Okay, so that's my slope. Slope equals 2. The y-intercept equals positive 3. Okay, and we can easily sketch a graph of this by then using those 2 points. So starting at our y-intercept, we can start at y equals 3 and then go up or down using the slope. So 1 over 1, 2 up. There's our point, 1 over 1, 2 up. There's another point, 1 over 1, 2 up. Okay, and we can sketch our graph based on that slope and y-intercept.